Good morning. Here we are, Tuesday, moving on to ecology, and today's going to be actually really, really simple. I'm going to bring it up. We're just going to roll right into it. Today, what we're going to be looking at are food chains. Yeah! All right, maybe not. If you are not somebody that saw that and went, yes, food chains, which I've had somebody do before, don't worry. I understand. So, we're starting off at the basics, right? Yesterday we went over living and non living, biotic and abiotic, those different parts of our environment. We took a look at the ideas of interaction and interdependence, the difference between two things influencing each other and two things depending on one another. A fox influences a mouse, it kills it and eats it. But the dodo bird and the dodo tree depended on each other. The dodo bird depended on the dodo tree for food, and the dodo tree depended on the bird in order to help its seeds to germinate and grow. So those are going to be the two differences. Now, as we move up from this, now we want to start looking at specific forms of interaction. And the easiest way to do that is food chains. Now, food chains, real simply, are a what eats what scenario. We want to identify in an ecosystem what are the predators, what are the prey, what is eating what. Now, you have all probably seen this before. This is not a new diagram, and I'm quite certain that previous years we have the sun shining light down onto our grass. And then this arrow to the grasshopper, to the frog, to the snake, to the hawk, and then finally to the fungus, our decomposers, right? This is the basic idea of a food chain. And you guys have all seen this before. Now, there are lots of different food chains. They're each going to vary based on the environment that an organism lives in. So while the corn may get eaten by the field mouse, which then gets eaten by the owl, we're not likely to find this food chain in the same area really where we find this bottom one. Because we're seeing different things, in this case, the corn being grown there. This top one is more likely to happen in a field, an agricultural center. This bottom one, more likely to happen where people are not getting involved in it. This middle one seems pretty normal until there's a lion at the end. Well, if there's a lion, this has got to be happening in Africa or one seriously messed up zoo. I don't know. Maybe they put Tiger King in charge of it. I don't know. Anyway, taking a look at these, it's all pretty straightforward. And what I've done is I have kind of recreated that last one, right? The one that was on the bottom here. Grass, the grasshopper, the frog, the snake, the hawk. I've recreated that here. But what I want you guys to pay attention to is going to be what is arguably the most important part for like a high school level, and it will help to explain why we see a ton of grass, a lot of bugs, some frogs, rarely see a snake, and big eagles and hawks are really super rare, right? And all of that actually comes down to the important thing. The important thing here is what does that arrow represent? When we see the arrow going from the grass to the grasshopper, what are we actually talking about? What does this arrow mean? Sure, you might look at it and go, oh, well, the grass is physically going into the grasshopper. That's also something that everybody should keep in mind. The arrow is saying what eats it. So, grass, what eats it? A grasshopper. Grasshopper, what eats it? Frog. Frog, what eats it? Snake. You guys hopefully get the idea. But the real key, what the arrow actually is energy. So, when you see a food chain, what it's actually saying is the energy of the grass is being given to the grasshopper. And then the grasshopper's energy is going to the frog. The frog's energy is going to the snake. The snake's energy is going to the hawk. You may notice something there. The word energy at each step is smaller than it was in the step before. What do you think that means? If we had to try to explain what's happening, why do you think it looks like that? That wasn't a mistake. I did that very much on purpose. So here we have a big lot of energy, and by the end, we have just this kind of little tiny energy. Well, it turns out most of the energy gets lost. It's just gone. Now, this diagram kind of sums it up pretty easily. It's colored in red and blue. It says at the bottom, red is the actual energy from one stage that's going to move to the next stage. So you can see here, down at the lowest level with the producers, our plants, you can see that that red comes all the way out to here, right? This much energy from the vertical all the way over to the blue is going to move up. And indeed, the next level up is the same size that that red was. This amount of energy, this blue stuff, is just lost. It's going to be kind of just released into the environment. It's the side effect of using it. It is heat. Living things produce heat. And so some of our energy gets lost as heat, some of it passes on. Now take a look at how this changes though. That means that from the total energy that plants have, which is huge, look how much energy makes it to this eagle at the top. Very little. Maybe, I don't know, like a 20th of the total that there was. It is a massive reduction. Now, let's take that into account for the animals that we see and the populations that we see. If you look out into a yard, just like whatever yard or field you may have immediately near you, look at all the grass, look at all the vegetation, look at all the plants that live there, trees, bushes, flowers, whatever. And then think, how many rabbits do you think could live in that same area? How many rabbits could be self contained in that field? They could wake up every morning, they'd each have space to live, they'd each have space to eat every single day, and just continue it on. All right, and then if we take a look at things like a predatory snake, or let's knock the snake out because snakes freak people out. Let's just say hawks, right? Red-tailed hawks, major predator for our biome, for this ecosystem. Look in that same field, that same yard. How many hawks do you think could be sustained by that 1 yard or field? Your answer is probably going to be zero. For most predators to survive, they need huge, huge territories that they can roam around trying to find food. Because they're going to get so little energy for every meal that a top predator, you may think, well, that's great. They're on top of the food chain, the best at natural selection. But the bottom line is a predator is either sleeping or hunting. And there's basically no in between. To put it in perspective, some animals are designed to live like this. Something like a lion. Lions sleep 20 hours a day. It's not because they're lazy. It's to try to keep their energy requirements down because a clan of lions, a pride, there we go, that's the word I was looking for. A pride of lions might be, let's say, 20 lions. How many animals do you think they have to eat every single day to maintain their energy? And in order to have enough land for that many animals, how much territory do they need just to generate enough food to keep themselves alive? This energy loss is a huge thing. And it makes up most of the ecological studies between predators and prey and stuff, is trying to identify this energy change. Now, Sometimes you're going to look at an environment and you'll be able to trace an easy food web straight through it, right? The grass gets eaten by the beetle. The fox isn't going to eat it. Robins don't eat it. The beetle gets eaten by our little wren, doesn't get eaten by mosquitoes, doesn't get eaten by bears, and the wren gets eaten by the eagles, right? But that doesn't represent everything that's here. And this is the major failing. While food chains are great, they're not necessarily accurate. Something like this for out west is an example of some of the organisms in an ecosystem. And if you look between it, there are lots of different food chains that you should be able to link through. One of the things that we're going to start looking at then is how do you build a food web from a food chain? Because while a food chain is good, a food web is even better. For today, though, we're just going to stop here at this food chain. Nice and simple. So, instead, let me show you guys what today's work is. Now, if we take a look, once again, inside the Schoology folder, you're going to see these different files, and this last one is the Eco Packet Worksheet. If you click on this, it is going to load a nearly 30-page packet for ecology. Now, we'll worry about doing bit by bit. For you, right now, we're going to work on the first, I think it's 6 pages. Now, you may sit there and go, oh my God, 6 pages of work, Matthews? Are you crazy? Um, no, I'm really not, because the first page is a title, the second page is a table of contents, the third page starts to explain a food chain. So if at any point you are confused, what is a food chain? Here it goes over all the different stuff, or even stuff that we have not talked about yet. Then it starts going into a food web, starts to describe the different levels of it, the energy flow through it. But this is the page that I want you guys to start at. It says, complete the food chain worksheet. Circle the organisms that complete the food chains below. So the sun goes into what? Which goes into the zebra, which then gets eaten by what? Once again, there's only like 5 of these, and it's literally just selecting which one of these species is going to be the best choice for what goes there. And then on the next page, on page 6, the last page, there are just some questions. Things like, what do the arrows in a food chain represent? We've already gone over that. Food chain starts with a what source, etc., etc. Now, some of these organisms that make their own food, organisms that eat plants, you're going to be able to find those right up here when it's talking about all these different organisms. But that's it. Just page 5 and page 6 of this packet. Do not send it to me yet. I will take the entire packet or a copy of it later in the unit when we get near the end. For now, I just want you guys to have the practice building some food chains, identifying what organisms would fit in where, and kind of recognizing how that energy is going to be affected. Tomorrow, we're going to try this video game food chain, food webby lesson thing. It should be, it'll be interesting. I promise you it'll be interesting. I can't promise it'll be good, but I promise it'll be interesting. All right. So, with that, I'll see everybody on Wednesday. Simple day, nice and easy. Stay safe and stay healthy.